Hello everyone, welcome back to the tree series. In this video, we will cover LCA of binary tree, that is lowest common ancestor of binary tree. This question is very important in the interviews. It has been most common asked questions in the trees in the companies like Microsoft, Amazon, American Express, Expedia, Flipkart, and it has been asked in many more companies. So we will try to cover the algorithm first and then we'll go to the implementation part. I will cover C++ code in this video and will attach the Java version of the code in the description box. So let's jump in. Okay, let's start the LCA part of the tree. So how do we start? We'll always start from the root node. At root, we will first check if that is equals to n1 or n2. That means these itself has a parent-child kind of relationship. In that case, that root node would be the LCA. So the first step would be check if root or wherever we are is n1 or n2. If it is there, or that means LCA is this root itself. That is the base case kind of situation. The second thing we will check is we will ask left. That means left, do you know who is the LCA? Right here, standing here, we'll ask left. Do you have any of n1 and n2 in your left? Then left will say yes, I have 3. So left will return us this 3's address. Then we will ask the right. So we'll ask right LCA is equals to, do you have any of n1 or n2? Right will say yes, I have 8. So if he has 8, so we'll say yes, 8's address will be returning. Once both the things are there, that means standing here, we know that one element is in the left part, one element is in the right part. Who is the common parent? Root itself. In case left LCA and right LCA both are there, we will say the answer is root. In other cases, whichever is there, let's say only left LCA is there, so we will return left LCA. If left LCA is not equals to null, else we will return right LCA. So what we are doing here is, we are standing here, we are saying that we will ask the left tree whether you have LCA. Left tree will say yes, let's say. We'll ask right tree whether you have LCA, right tree will say yes. In case both are saying yes, that means this right here is the common parent. So this is the point 4. That means left LCA is also saying, what is left LCA? That means we want to find out that whether any node n1 or n2 present in the left. So the answer would be yes, this node itself. In other cases, let's say n1 is 4 and n2 is 9. n1 is 4, n2 is 9. In this case, left will say that I have 4 and 9. That means left will say that I have one of these nodes or both of these nodes, but right will say no, I don't have. So in that case, we will say whatever left is saying, our answer would be the same. So this is how LCA's algorithm works. Now I know that is not easy. This is not easy to understand from the first view. So we will dry run it and understand that how it actually works. Now let's try to dry run the LCA where n1 is 3 and n2 is 2. So we'll sit it here, that is the root node. At root node, we'll check if 1 is equals to 3 or 2. No, it is not. Then we will go to the left. Left 5. Is it equals to 3 or 2? No. We'll go to again left. 4. Is it equals to 3 or 2? No. We'll again go to left. Its left is not there. We'll get back here. 4's right. Now we'll go to 9. If 9 is equals to 3 or 2? No, it is not. So it is not. So we'll come back at 4. At 4 everything is done. We'll get back at 5. At 5 we have to check the right part. Now at 3. At 3 it is equals to 3. That means we have found the one element of n1 or n2 whatever like is equal to the root's value. That means from here only we will say we will return the address. That means 500. Here we will return the address. Then 5 itself will return the address to the root node. At root, we will receive that there is one element that is on the left and its address is 500. Now at 1, we will go to the right side. Right side is 2. 2 is equals to 2. Yes, that means its address will be passed over as 300. At root, we got the left part as well as the right part. That means at root, one of the elements are in left and other one is on the right. That means the root itself is the LCA. So this is the simple dry run of this question. Now we will write the code. This is the lead code's code that we are trying to submit. In this, we are given the root as well as one node n1 and another node n2. So first, we'll write the base case. If root is equals to null, that means root itself is null. There is no tree. That means in that case, there is no ancestor. So we'll return null. If root's value is equals to n1 or root's value is equals to n2, that means one of the nodes that they are given us to find the LCA for is equal to the roots itself. That means root itself is the LCA. So we'll return root. Right? In other cases, we say let's find out which one of the node is in the left part and which one is the right part. So we'll write left LCA is equals to, we'll call this method lowest common ancestor, but try to search on the left side given n1 and n2. Similarly, we will try to do the same thing, saying that we will try to check whether any element from the n1 or n2 are on the right side. So we'll write lowest common ancestor, roots left and then roots right, comma n1 and n2. Once this is done, now we'll check if left LCA and right LCA both exist. That means wherever we are standing, one of the element is in the left part, another element is in the right part. That means root itself is the answer of the LCA because it would be the common ancestor. So if left and right exist, we will just return, you can also write in the brackets, return root. In other case, we will check if left LCA alone exists, then we will return left LCA. Else, in all the other cases, we'll return right LCA. So what we are doing here is we are first checking whether the value where are we standing is one of the nodes that we are searching for. If yes, then that is the LCA we know. Otherwise, we will go to the left part of the tree as well as the right part. Now, if left and right both exist, that means where we were standing, that is the answer. Else, whichever is giving us the answer, that is the LCA of the binary tree. So, I know it's little tricky, but with practice, you will be able to submit it, right? I will attach the link for this question where you can submit this on LeetCode along with my submissions in C++ and Java. You can refer to those codes. In case you are finding any difficulty in understanding it, I would be very happy to help you. Please let me know in the comment section. And thank you for watching the video.